What we're doing today is we want to do a demo of how our filters work. Now we've got two filters. As Ross said, we've got the oil and sediment filter, which is the Green Rhino oil and sediment filter, and we've got the sediment only filter, which is the yellow one. As you can see, this is a lot thicker. The oil and sediment filter is a lot thicker than the sediment only filter. Your company have expressed most interest in the sediment filtration system, so this is the one we're going to be demonstrating today. What we've done is we've mocked up a quick site test. This is as near to as we can get to like a pumping test that you carry out on site. We've got a holding tank which is full of water that we're going to add a pollution to. You've got your generator over here with a 2-inch submersible pump that's running around to the pallets over here, or the raised section that we're going to have the filter on. Normally you'd have your lay flat hose which would be laying down to a gully, and that's how the lads would normally set the site up. So what I'm going to do is I'm going to add this pollution event to the water. Now what we've got in here is we've got some sand in here, we've got some clay out your muck pile over there, which will emulsify obviously once we get in the water, and we've got a bit of kiln dry sand which is down to about 0.1 of a millimetre, so very, very fine sands. Now I'm going to set this up. I've already got the submersible pump in what would be the excavation. We've got the blue hose around the back here, and I'm going to connect our yellow sediment system up to the blue hose. Sediment system's very, very conveniently we've got the instructions on here. You insert the blue hose down to this line here, which is conveniently marked on here, shows it very, very clearly. Normally, company would have their safety logo message, or you could have your company logo on there, or your safety message printed onto the filters. And then at the bottom, what we've got is a hydrocarbon detection strip, which will measure, it will monitor the water, and if there's any hydrocarbons present, as Ross showed you in an experiment earlier, that will turn from a light blue to a dark blue. These are fitted on both systems. These are fit to the sediment system and they're fit to the hydrocarbon system as well. So I'm going to connect that up to this blue hose by simply pushing the hose down to the insert to this line mark, which is on the bag. On the yellow system you can actually see the blue hose inside the system. That one is a little bit harder, but you can feel where it is. It's very, very quick and simple operation. We supply a reusable cable tie with every system, whether it's a sediment system or hydrocarbon system, and that goes around the collar, about midway down the collar. You can adjust the flow. If you've got a powerful pump, you can sometimes adjust the flow of it by just pulling that cable tie a little bit tighter. So we're going to start adding the pollution to the water. Try and get over there. So what we now got is a very dirty excavation, the usual thing that you find on site. Contamination might be caused from a number of different aggregates. Could be silts, sediments, sands, topsoils. So we'll let that permeate around the water first of all. I'm just going to start up the generator now. What this is designed to do, it's designed to catch down to 100 microns. As you said, the hydrocarbon system will collect up to 2.5 litres of hydrocarbons. This system will capture sediment and silt down to 100 microns. So, you know the debris kind of wash off that you get down the road when guys carry out the pumping operations on site? That will capture all of that. You may get some emulsified sediments, so occasionally you may get a slight muddy tinge to the water, but essentially what you're washing down the road is sediment free. You're not going to start jamming up the gullies with it, you're not going to jam up your combined sewer systems with it, so kind of mitigates that risk. Now you can adjust the cable tie. If you come and you're getting a little bit of seepage from the collar, which we're not in this instance, you can adjust this cable tie, make it a little bit tighter. If it's not flowing well, you can slacken it off slightly. The guys can monitor that hydrocarbon detection strip. If that starts changing in any way, shape or form, you know you need to stop the pumping operation and maybe look how you need to readdress that situation. So we're going to let that pump away for sort of 5–10 minutes. What we might do is to really accentuate the test. We might move some of that sediment so it's getting picked up by the pump. Normally the lads would dig a sump out, they might put a bucket in there and then stick the sub pump in the bucket. So we might move that sediment around just to get a good load of sediment into that through that filtration system. What I'm going to do is I'm going to take a couple of samples now. I'm going to just stick my arm into here and we'll see if we can get some of the gear that's coming through this filter. I mean, it's a dirty, mucky mess. It's going to inevitably end up washing down the road. Just going to stick that there. Now what we got here, I mean, I've just taken a random sample from here. Now, as you can see, there's a slight cloudy tinge to it. You wouldn't want to drink it, no, but I'd rather be putting that down into the gullies and the systems than I would that. What we're going to do at the end of here, we're going to take some samples. We've got some lab bottles here. We're going to take some samples of this water. We'll seal these on site now. We'll label those up. We're going to send those off to a lab. And then part of what we're going to do is actually we're going to get those results back and we'll send them to you guys to have a look at. And in the past, the samples we've had back they've been minute. I mean, we've had samples that we don't even get readings off. We've had 0 parts per million of sediment within samples that we've sent off. If we do, it's going to be minimal and well within kind of discharge parameters. I'll just show you quickly. This is a pump. This is a filtration unit I used earlier. It's made up of a nylon monofilament, which is 100 microns. And this is what filters all the way through. This is what filters the sediment down. You can see the sediment that was captured in here earlier. Now we can adjust that. If you're having problems where the water is particularly silty, we can reduce that micron down to 50 microns or even less than that. Sometimes if you want to get a decent flow on it, we may increase that. If silt's not a problem and it's more of a ballasty ground, sandy ballasty ground, we might increase that micron so you get a decent flow of water. Now you can pick the filter up. There's a carry handle here, and we've got a carry handle down here, 2 carry handles down here to stop any sediment falling out. It's been designed to hold about 20 kilos, which is the maximum one person lifting weight. There's not 20 kilos in here, but we'll just move this over to the white sheet over here. So you've got your 2 handles. And there's your potential pollutant which could have ended up down the drains, down the road, contaminating gullies, your highway gullies and your combined sewer systems. I mean, we were running that for a few minutes. The lads might have that going for a few hours, so you can see how much potential that might pick up over like an hour's pumping, a couple of hours pumping. So it's going to save the guys a lot of time on site. The guys would normally have to clean this up at the end of the day. They'd have to sweep this up, chisel it off the road when it's gone hard. So it's going to speed up their working day, make things easier for the lads on site as well.